Hello everyone, this is Sir Deson, and in this video, we are going to learn on illustrations of quadratic equations. But first, we need to define what is quadratic equation. A quadratic equation is also known as second-degree equation because the highest exponent of the variable is 2. Now consider the following equations on your screen. We have here 5m minus 8 equals 0, 3x squared plus x equals 2, x cubed plus x minus 5 equals 0. Now which of the following is an example of quadratic equation? You have 3 seconds to choose. Your timer starts now. Okay, time is up. The correct answer is equation number 2. Now, why is it that equation number 2 is an example of quadratic equation? Okay, equation number 2 is an example of quadratic equation because based on the definition itself, that a quadratic equation is a second-degree equation because the highest exponent of the variable is 2. Now, in equation number 2, the highest exponent of the variable x here is 2. Therefore, equation number 2 is an example of quadratic equation. In equation number 1, this is not an example of quadratic equation because the highest exponent of the variable m here is 1. Take note that if there is no visible exponent, it is understood that the exponent is 1. Now for equation number 3, this is also not a quadratic equation because the highest exponent of the variable x here is 3. Furthermore, the standard form of quadratic equation is ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a should not be equal to 0. In the equation, ax squared is the quadratic term, where you can find your a beside x squared. Bx is the linear term, where you can find your b beside x. And c is the constant term. Now question, why is it that a should not be equal to 0 in the equation ax squared plus bx plus c equals 0? Any idea? Okay, a should not be equal to 0 in the equation ax squared plus bx plus c equals 0 because if it happens that the value of your a is equal to 0, your quadratic term will become 0. And your equation will no longer a quadratic equation. It will become a linear equation. Are we clear? For example, we have here 2x squared plus 5x minus 3 equals 0. Now, this is an example of quadratic equation in standard form because it is already arranged from quadratic term, linear term, and constant term. So, since this is already arranged in standard form of quadratic equation, you can now identify the values of a, b, and c. So the value of your a here is 2, that is beside x squared. Your b is 5, that is beside x. And your c is negative 3. Another example, we have here 7x squared plus 3 equals 0. This is also an example of quadratic equation in standard form, but there is no linear term. So since there is no linear term, so it is understood that the value of your b is equal to 0. Your a here is equal to 7, that is beside x squared. Again, your b, that is your linear term. So since there is no linear term, so the value of your b is equal to 0. and your constant term, which is your c, that is equal to 3. Another one, we have x squared plus 6x equals 0. Now, this is also an example of quadratic equation in standard form, but you don't have a constant term. So, since you don't have a constant term, it means that the value of your c is equal to 0. So, we have here the value of your a is equal to 1. So, since there is no visible coefficient here, so it is understood that the value of your a is equal to 1. Your b is equal to 6, that is beside x. And again, since you don't have a constant term, so the value of your c is equal to 0. Another example, we have here 3x times the quantity of x minus 2 is equal to 10. So this is an example of quadratic equation. However, this is not written in standard form. So to rewrite this one into standard form of quadratic equation, we need to expand the product of the left side of the equation. So we have here 3x times x. Okay, we have here 3x squared. 3x times negative 2. We have negative 6x equals 10. Okay, after that, make the right side of the equation equal to 0. So to make the right side of the equation equal to 0, you have to subtract 10. Both sides of the equation. So we have here 3x squared minus 6x. Again, subtract 10, both sides of the equation. We have minus 10 equals 10 minus 10. So after that, simplify. Okay, so we have 3x squared minus 6x minus 10 equals, okay, 10 minus 10, that is equal to 0. If you try to look at the equation now, the equation is now a quadratic equation in standard form because it is already arranged from quadratic term, linear term, and constant term. So since this is already arranged in standard form, so you can now identify the values of your a, b, and c. So the value of your a is equal to 3, that is beside x squared. B is negative 6, that is beside x. And your c is equal to negative 10. Okay, last example. We have here the quantity of 2x plus 5 times the quantity of x minus 1 equals negative 6. So this is also an example of quadratic equation, but is not written in standard form. So again, to rewrite this one into standard form of quadratic equation, we have to expand the product of the left side of the equation. Okay, we have here 2x times x. We have 2x squared. 2x times negative 1. We have negative 2x. Positive 5 times x. We have positive 5x. Positive 5 times negative 1. We have negative 5. We are just simply applying the FOIL method. That is first, outer, inner, and last. Okay, copy. Negative 6, no? Equals negative 6. After that, you have to combine like terms if there is any. Okay, copy 2x squared. This one, these two terms here are like terms, so you have to combine that one. We have negative 2x plus 5x. We have positive 3x. Copy negative 5 equals negative 6. Okay, after that, make the right side of the equation equal to 0. Okay, to make the right side of the equation equal to 0, we have to add positive 6 both sides of the equation. Okay, so we have here 2x squared plus 3x minus 5 plus 6 equals negative 6 plus 6. Okay, after that, simplify. We have 2x squared plus 3x. These two terms here are like terms, so you have to combine that one. Negative 5 plus 6, that is positive 1, equals negative 6 plus 6, that is equal to 0. So, this equation now is a quadratic equation in standard form. So, since this is now the standard form of quadratic equation, you can identify the values of your A, B, and C. The value of your A here is 2, B is 3, and your C is 1. Okay, at this point, I would like you to answer this one. Kindly write each quadratic equation in standard form, then identify the values of A, B, and C. Okay, I think that is all. Thank you for listening and watching, everyone. God bless.